Morning, everyone. Oh, I'm like super loud. It's like, can we turn the volume down just a smidge? Thank you. Yeah, welcome, everyone. Thanks for braving the transport struggles. I know there's a few challenges getting around Berlin this morning. Luckily, I'm staying nearby. This is my fourth, I think, microXchg. I think I missed the first one, but love this conference. It's a great conference, like to chat with fellow practitioners, share ideas. So I'm around all conference. If you like what you see, if you don't like what you see, come and chat to me afterwards. Yeah, I won't take offense. I love to learn stuff, so please do come and have a chat to me. But we are looking at creating an effective developer experience for the next 50 or so minutes. It's going to be a high-ish level talk, so if you do want to get out and go to another session, I won't be offended. I am going to be mentioning a whole bunch of Kubernetes. I am going to be mentioning a whole bunch of Envoy stuff, but it will be kind of from a higher level thing, yeah? So the core premise of the talk really is about how do we take our ideas, or our teammates' ideas, and deliver value to our customers. That's it in a nutshell. Now, most of us in this room are probably creating software to deliver value. You don't have to, but most people, like I say, most people in this room, kind of self-selecting bunch, we're creating software, and many of us are embracing what we're calling cloud native. Yeah, I use sort of inverted quotes, but things like Kubernetes, Nomad, Mesos, Amazon, Google, Azure, a bunch of other things, we're using these technologies to deliver that value. Now, the interesting thing is what goes on in the middle here. Yeah, I've been writing software since I was like 10 years old on a CPC 464, 64K of memory. The way I deployed software back then on a cassette is very different to the way I deploy software in the cloud area now. We all know when it goes well, yeah? Continuous delivery, I'm not going to talk lots about that today, but continuous delivery is a super important topic. I've got other presentations that look into that, and it's all about speed and stability. Can you optimize your feedback loop to go as fast as you want to, or faster than your competition? And can you be stable? Deliver software that doesn't fall over, and deliver software that doesn't get breached in terms of security. Can you do it fast? Can you do it in a stable way? Loading it on the ship effectively, we all know when that goes well, it's a good feeling. The challenge is, many of us in the cloud native space are using tooling which is not quite there yet. Yeah, not quite where you want. Loading stuff on goes a bit wrong, or even worse, you get into production and stuff's going wrong. You don't actually know why. These are really challenges, big challenges. This, for me, is developer experience. Yeah, engineer experience. Call it what you will. These days I do dev and kind of opsy stuff. But this is what we're going to be focusing on from a high level today, as in what sort of in the middle are the challenges, and how have I and my teams overcome some of the issues, and how have we made some mistakes as well. I kind of share my learnings, but that's what we're focusing on. So this is me, at Daniel Bryant UK on the Twitters. Love getting involved in Twitter. I've done an interesting kind of career from academic, did some work for the UK government, did a whole bunch of work for startups. Now I mainly work, I'm an independent consultant, but I mainly work at DataWire, Boston-based company. We do the Ambassador API gateway for Kubernetes, open source, and we also do the Telepresence tool. Telepresence is a CNCF-hosted tool, but we are the ones that steward it. And I also write for InfoQ a whole bunch. So you'll see me reference lots of InfoQ stuff, because that's my kind of go-to site. Java is my native language, other than English, so to speak. So I code quite a bit in Java these days. Just put a book out with my friend Abraham Morin-Prez. Would love your feedback on the book. So if you do Java stuff, we talk a lot about Kubernetes, a lot about cloud tooling in that book as well. It came out just before Christmas. So super excited. Writing a book is a lot of work. I'll tell you that up front, as in I didn't realize how much, but it's a lot of fun. I learned a lot by doing that. So, DevEx 101, moving along. I first bumped into this topic, sort of the latest imagining of it, in New York a couple of years ago. From Adrian Treneman, he's a senior VP of engineering at HBC, previously Gilt. And he said that DevEx, developer experience, is about reducing engineering friction between creating a hypothesis, coming up with an idea, and delivering observable value to users. Yeah, that's what DevEx is in a nutshell. Observable experiments, observable value in production. Notice observable is super important here. And also notice hypothesis. We're not necessarily doing waterfall stuff now. We don't know what our customers exactly want, so we have to create experiments. Yeah. DevEx isn't new, and I hope we're going to see this book a whole bunch at the conference. Fantastic book, Accelerate, from Nicole Forsgren, Jess Humble, and Gene Kim. They were the ones behind the State of DevOps reports, these kind of things. And also, of course, Martin Fowler, when he started talking about you must be this tall to use microservices, pulling out a few bits of each of sort of those, the books and then the blog posts. Things like the top three here, lead time, deployment frequency, mean time to restore, they're all developer experience concerns. Yeah, if I can't deploy rapidly as a developer, I can't optimize for feedback. If I can't figure out what's gone wrong, I can't get a higher mean time to restore. Same thing with what Martin says. Martin said, you must be this tall to write microservices. He said rapid provisioning, basic monitoring, and rapid app deployment. DevEx kind of stuff again in my mind, yeah? This stuff isn't particularly new, but the packaging of it is quite important. Now, at a very kind of meta level almost, there's three components, I think, within DevEx, yeah, and this will frame some of the more technical stuff I'll go into in a minute. The first is DevOps. Yeah, I think DevOps, has been fantastic. It is a nebulous term. DevOps means many things to many people, but the DevOps Handbook is my go-to reference. And really, when I say DevOps, I kind of mean aboud dev qua ops. Yeah, business, dev, QA, ops. All of us working together to deliver value. Also, I think lean is super important. Minimizing waste. Me as an engineer, maybe I don't want to be spinning up infrastructure. Maybe I don't want to be continually building my containers. I just want to code and get my stuff out there. And UX. And I'm not just talking about front-end stuff. I've done my time in the front-end space, but I'm talking about UX in terms of how we use our tools. Often our build tools, our deploy tools, are something we use like multiple times a day. But we invest no time in these tools. Who's written a janky kind of shell script? Yeah, we've all written janky shell scripts that kind of get us to a certain point, but we really need to think about the UX to maximize kind of the value. So as I mentioned, DevOps is all about optimizing for feedback, optimizing for learning, improving flow. Lean is about minimizing waste, and this screenshot comes from Adrian's talk, where he was talking about minimizing the kind of lost cycles as an engineer, where you're just compiling or building images, these kind of things. And being a little bit sort of intentional about how we design some of these things. Yeah, from a UX perspective, this book, The Design of Everyday Things, is a fantastic book for just thinking about how we as humans interact with the world around us. So I'm going to look a whole bunch today at platforms. That's kind of like the framing of this particular version of the talk I'm going to do. And the workflow is massively dictated by the platform you build. Now, I think kind of Kubernetes is a great foundation, but it's not a complete platform. Yeah, and I'll go into more of that in a second. That's kind of the framing. So just the level set. We all sort of waterfall. When I started my career, the ideal kind of workflow was waterfall because we thought we knew all the requirements up front. Yeah, but we didn't, obviously. For the large amount of projects, unless you're building a nuclear reactor or some kind of medical system, you probably don't know stuff up front. We then moved to what I call mini waterfall or agile. Yeah, so agile is kind of repeating the waterfall style steps, but much faster and much more iterative. And now we're arguably moving to something else that is enabled by things like cloud technologies. And Netflix have called it their full lifecycle developers. Cross-functional teams, product people, front-end engineers, back-end engineers, ops, QA, SRE, all bundled into one team, kind of autonomous units, if you're familiar with Spotify, tribes, all that kind of stuff, and fully responsible for a product, and they should in theory be loosely coupled with the rest of the organization. We've talked about a whole bunch of this stuff at DataWire as well. What we're starting to see over the last sort of 6 months or so is some of this kind of final stage here is being lumped into a term called progressive delivery. Now, yes, another buzzword, and I'll break that down in a second, but it's an interesting idea, and James Governor talks a lot about this at RedMonk. If you haven't heard of the term, it is fundamentally things like continuous delivery, and in the Launch Darkly, people have basically said this, but wait, isn't this just continuous delivery with a new name? But there's a few more nuances in terms of separating deploy and release, and giving the power of releasing functionality to product owners. Things like feature flags, things like canary releasing. We as engineers perhaps don't want to control the release. Perhaps the business folk, and I've used that term kind of loosely because we're all business folk, but the business folk want to monitor the release of new functionality. That's where progressive delivery is slightly different. Now, it does require a bit of different tooling. You need observability into your stack. You need to understand kind of top-line metrics from an engineering point of view. You also need to understand business metrics to make sure a new release of software is going well. Yeah, And it also requires feature flags, same kind of thing. And the challenge with some of this stuff, Stefan actually pointed out last year, in a great talk last year. It's on YouTube, on InfoQ. And he talked about microservice anti-patterns and patterns. And we've already talked about autonomous cells seems like a good way to organize ourselves. Product-focused teams, full life cycle. But the anti-pattern Stefan mentioned was micro-platforms. And I've literally seen this myself. I worked on a project in the UK about 4 years ago where we had Ruby, Java, and I think Go in the stack. And we had service discovery implemented in 3 different technologies. We had circuit breaking, 3 different technologies. And the Hystrix in Java was subtly different than the Hystrix circuit breaker in Ruby. Absolute nightmare, yeah? And the way we were doing feature flags was through libraries in different languages. And this led to a lot of coupling between the different languages. And when we updated one library in, say, Java, we had to remember to update the Go and the Ruby ones. Bit of a nightmare. Stefan did a great job of breaking it down even further. But what I've come to realize really is we need to push a lot of this stuff, if we can, into the platform, into a kind of centralized platform. Yeah. Now, if you're a single language stack, like if you're a Spring Boot shop or a Go micro stack, maybe libraries are the right choice for you. I'm not saying don't use libraries, don't use SDKs, because for a single language shops, they can be fantastic for productivity. But a lot of us are mixing up different languages, a bit of Go here, a bit of Java here, whatever. And therefore, you want to push a whole bunch of this kind of cross-cutting concerns into the platform. Yeah. Now, you've probably got teams around this kind of centralized platform here. Maybe you have Kubernetes, some developer tooling, CI/CD stuff. But the teams around the edge here maybe are going at different velocities. Maybe they're at different stages in their life cycle. Maybe some teams are prototyping ideas. Some are running the production experiments. And some have got mission-critical systems. Therefore, their needs are going to be subtly different across the teams. And the platform has to respect that. The platform has to offer a sane path by default, but allow people to kind of get off if they need to do certain things. Yeah. And I think, I've got to quote Kelsey Hightower in any kind of cloud talk that I do. Kelsey is the legend that he is. But he said it really well here. Yeah, I'm convinced that the majority of people actually want a PaaS, a platform as a service, something like Cloud Foundry, something like Heroku, but they just want it to be built by themselves. And hands up, I've done this a couple of times myself. Yeah, the project I mentioned earlier on, my team and I, we built a PaaS. Project after that, we accidentally built a PaaS as well on Mesos. So I've kind of been there, yeah. And Kelsey's point really is, there's nothing fundamentally wrong with building a PaaS, but just know you're doing it. If you're going to go all in on Kubernetes, you're going to need to develop a few extra tools around the edge. Is your engineering team up for that? Both from a skill point of view and critically from a time point of view, yeah? There are teams that are doing these things. I learned a bunch from Netflix, they're actually using Mesos and Titus. They're not using Kubernetes, but similar kind of principles. They are building this paved road, PaaS, that provides a default way for engineers in Netflix to ship software. Now, Netflix embrace what they call a freedom and responsibility culture, F&R. If you ever chat to a Netflix engineer, you'll always hear F&R being mentioned, freedom and responsibility, and that they have this paved road. It has sensible defaults, and if they follow that and they use that, they get a lot of support from their centralized engineering team to help them. They can totally go off this paved road, do their own thing, but they don't get quite as much support. So the teams have to weigh up. Do we need different functionality than is provided by this central kind of PaaS? Yes, we need to support it. We need extra resources. It's all a trade-off, yeah? Shopify, last year at KubeCon New York, I learned a bunch from Nico Curti. Massive hat tip to Nico. He's actually contributed to some of our DataWire stuff now, which is super cool of him. But he talked about how Shopify were loving the Heroku experience. They were doing some fantastic deployments and work on Heroku, but Heroku wasn't scaling in some aspect. Shopify is, e-commerce as a service. They're doing really good business, and that their actual tech was holding them back. So they took a fundamental decision to build a platform on top of Kubernetes. And he broke down, the talk is available on InfoQ, he broke down all the decision points in the team. And in the end, they actually created a Heroku-like experience running on Kubernetes. They didn't, I think they're changing it actually now, but at the time, they didn't expose kubectl to their engineers. They get pushed, and stuff magically happened in the background. Yeah, and the power users could do kubectl and various things. And they also even exposed a web UI that basically put a nice front end onto kubectl. And that was because they chatted to their engineers. They said, look, we're building this platform. We're liking this thing called Kubernetes. And the developers were like, yeah, we don't really care about Kubernetes. We like the Heroku experience. So Nico and his team were like, so I'm not going to teach them kubectl. They don't care about ops stuff, yeah? Well, they do care, but they don't. They primarily want to just push code. So Nico and his team built kind of like Kubernetes was just the engine of the platform, and they created a facade around it that mirrored Heroku, which I thought was fascinating. And I'll go into some more details on how they did some of that stuff, because I learned a bunch from that. But my point here is you totally can create a PaaS on Kubernetes, on Nomad, on Mesos, take your pick. Even if you use something like EKS on Amazon, you might need to do more PaaS-like stuff around it. But just know what you're doing. It's always a trade-off. Using something like OpenShift or something like Cloud Foundry, something like Heroku, versus building your own thing. I get super excited about technology sometimes. I went Docker crazy. I went Kubernetes crazy. But it's a cost. When I'm an engineer and I'm delivering value to my organization and to my users, I need to be more responsible with that cost, with that choice. So the fundamental question is, should I build a PaaS on top of Kubernetes? And I'd like to sort of throw out about sort of 5 questions which I've made a bunch of mistakes and I wish I'd asked myself up front, or I've sort of learned from other people along the way. And even if you're not using Kubernetes, hopefully this is a question around sort of building your platform, your developer experience. Now, the first, in terms of fundamental questions, do you understand your domain? Vaughan's going to be talking a lot tonight around domain-driven design. Always love Vaughan's stuff, so definitely check that out. But this is really critical. Is your problem domain complex? And do you have product market fit? If the answer is no to any of those questions, I'd probably say don't worry about microservices. Probably just build a monolith, and probably don't worry about Kubernetes, And if you do want to go containers, you can probably get away with just running it like on something super simple, maybe App Engine or Elastic Beanstalk, You don't really need Kubernetes if you've just got this one kind of simple monolith, Is your solution event-driven and quite simple? Should you be adding value elsewhere other than building a platform? If the answer to these is yes, I think go with serverless. This is the best joke in the presentation, so just to set expectations. Or go with App Engine and Heroku, or something like that, or Elastic Beanstalk. These are I'm not going to cover too much today, but I always like to remind people, as in if you're engineers, we sometimes miss the obvious sometimes. If you haven't got product market fit, why do you want to spend all this money building a platform on Kubernetes? Probably should be solving your business problem first. If you are going to go on to Kubernetes, Kubernetes I think is a fantastic, one thing that's really nice, there's many nice things, but one thing that's really nice about Kubernetes is the team that built it thought about kind of open for extension and closed for modification. When I first used Mesos, it was really hard to do to kind of build stuff around Mesos, and getting like commits into the code base was just a nightmare too. Whereas the Kubernetes community are much more welcoming, but the way they've designed the actual framework, it is becoming the de facto platform now, kind of regardless, to be honest, almost a new cloud broker, and you can get it pretty much everywhere. But the key thing is there's really good extension points if you know where to look. Things like custom resources, CRDs, custom resource definitions, and controllers. And also Red Hat have gone with the operator pattern. And the Shopify team have got this thing called Cloud Buddies, which is basically sort of a building on top of the operator thing. And I've referenced a couple of things here as well. They're extensions where you can enable custom workflows. All that kind of custom resources are is an API to define entities. So you can declaratively define, a Redis cluster, or you can declaratively define how a etcd cluster works. Or you can declaratively define something that's unique to your business. You don't have to stick to the ingress, service, deployments kind of model in Kubernetes. That is a great model, and most time we do use that. But you can extend using these custom resource definitions. There's some fantastic examples out there, and the Operator SDK makes it easy to write these custom controllers. You can write them in Go, Ansible, and there's a couple other ones as well. And I think I've got a couple of links there. So to learn more about operators, definitely check out the Coaas website. One other way to think about operators is it's basically coding human knowledge into an automated fashion. So if you've got this kind of janky service that needs a bunch of stuff to happen if something goes wrong, well, if you can monitor that when it goes wrong, and you can script the fix, you can write an operator to do that. We don't have to log in and fix stuff anymore. We can write an operator to automate that. And that's just one example. You can do many other things with operators. But Nico and his team created a bunch of what they called cloud buddies. I don't think he used the operator pattern. I think he actually did custom resources and controllers. They manually coded these things. But then their dev team basically just put a very simple YAML saying, I want a Redis cluster, and these are the semantics of operating it. I want a, I think it was Kafka cluster, and a bunch of other sort of Shopify-specific business cases as well. And the developers simply had to learn some YAML. They had to learn a very simple API, which behind the scenes was being automated and being operationalized by these custom resources and these controllers, which I thought was really nice. And just the API basically allows you very easily to extend Kubernetes. I've seen some people try and extend it by writing things on kubectl or doing weird kind of things with Kubernetes itself. And I think really it wasn't designed that way. Know your extension points, use things like custom resources. And I've got a few links down there for you as well if you do want to explore these kind of things. Now, I did mention like continuous delivery. I'm not going to talk a lot in this talk. I've got a bunch of other talks on YouTube that go into it in more detail. But I do like this notion of what some people are calling GitOps. Yeah, I don't know if people have bumped into GitOps, but the Weaveworks team are talking about it a lot. And it's basically driving your cluster state from Git. Yeah, so Git is kind of your single source of truth. And then there's like this flux operator that continually looks in your relevant Git repository, say your production Git repository, and it will sync what it sees in terms of the YAML config and the images to be rolled out with the production cluster. Now, if you change your YAML in Git, it will make sure the cluster synchronizes. And like if the cluster dies or the cluster, bits of it fall over, it will again trigger like in a declarative way, so if it's almost idempotent, it will stand up the cluster in the way that it's defined in Git. There's many, I like this a lot. I mean, Kubernetes at its core is declarative and it's kind of got that control loop thing going on, but Flux extends it by encoding all your artifacts, including all your config, into Git. And using this flux operator as a control loop. Anyone who's done robotics, the kind of control loop, which continually looks at your single source of truth, Git, and then synchronizes your cluster. This is a great example of how to use an operator, I think. Moving on, next question. How quick do you need feedback? And one thing I really struggled, and this is actually when I was using Mesos like 4 years ago or so, was this loop, kind of crazy loop. I was doing Java development, and I had to code my Java app. And when we got a few services going, then we were having to deploy them into containers and ship them up to like a QA environment. And as a developer, I was coding, and I'd build my image, I'd push my image. It was quite a slow feedback loop. Yeah, and I borrowed this from Microsoft. They've talked about sort of the kind of the loop. If you're containerizing your app, it's a bit of a clumsy loop, to be honest. Yeah, and like any kind of things, many engineers have spotted this and gone, I'm sure we can write some tooling to make this less painful. Yeah. Now, hat tip to Shahid did a great blog post, and I think he's got a talk online that compares a bunch of tools that look at automating the inner dev loop. Yeah, that kind of, like if anyone's used, like, say, hot reload, like particularly if you're doing front-end stuff, or even back when I was doing Spring, we had like a hot reload where I could change the code, and it would, in the background, recompile and redeploy, and I could see my changes, like, in near real time. That's what a bunch of these tools, so Draft, GitCube, Helm, well, Helm kinda, but a bunch of these tools that are out there that do help you automate this in a loop. Get rid of some of that waste where I'm continually writing docker build -t, and all this kind of stuff. There's also some interesting packaging popping up around not just packaging your app in a container, but packaging the supporting infrastructure. And there's a project called Helm. If you haven't looked at Helm, thoroughly recommend that. You can kind of package a bunch of stuff together to kind of a product or the result of a project. And Matt Farina has written a couple of great blog posts that really helped me understand where kind of Helm sat in the stack compared to tools I was used to using. So a lot of people use Helm, whereas really I think they want to use something like Helm File. Just a heads up on that one. So Helm is kind of more your package manager, and Helm File is a declarative statement of what you want actually running. So I see people trying to abuse Helm to make it do what it wants, and there's actually tools out there that already do what they want. They just don't know about them. And I've been there, but these two blog posts are really good to read if you want to understand how to automate and how to automate the packaging and the rollout of sort of your container-based apps. Just a little bit further, a few other tools I'm super interested in. And this is, apologies, a bit of a brain dump, but you can look at the slides later on and follow up some of this stuff. Out of all these tools that kind of do automate the inner dev loop, I'm particularly interested in Garden. Garden's it's a nice way of kind of packaging up dependencies as well. So you can say, this is my app, my service, and it's dependent on these other services. And if I rebuild something and I need to trigger a rebuild of other dependencies, Garden will do that. If you ever use Terraform, Terraform has graph theory behind it. So if you change the resource, it will check what other things are impacted. Garden's trying to do that for container-based apps. Yeah, it's not a direct analogy to Terraform, but I like the kind of model of they're building this kind of richer model of your entire system, and then it can look for dependencies when you're changing things. Bunch of other things, Helm and Ksonet for packaging, telepresence I've got to mention because it's a data wire tool, but it is fantastic, and I'll go into more of that in just a moment. But these things help, like telepresence, basically you can put your laptop in the cluster. That's our kind of pitch on that one, which is nice if I'm, say, coding a Java service and I want to debug locally, but I want to hook up to some remote services. So I use telepresence a bunch for that. There's other tools I'll mention in that space in just a minute too. Conveniently, that does actually lead on to the next question, is do you want to develop services locally or in the cluster? Yeah. Now, often when people start using containers and so forth, they're just using Minikube or Docker for Mac, running stuff locally. But when you get to a certain point in terms of size, often you have to start using remote environments because you cannot possibly spin up your entire stack even on a powerful Mac. Yeah. Cindy Sridharan has done some amazing work on this. If you want to Google Cindy Sridharan, copy construct on Twitter and on Medium, she's gone into much more detail than I have. So hat tip to Cindy there, fantastic work. But there are many advantages to working locally. And if you kind of build your microservices correct, in quotes, you should really be able to work locally. You should be able to mock out dependencies, maybe use stubs, something like service virtualization. I did a whole bunch of work on Hoverfly. People haven't seen Hoverfly, check that one out. Open source tool for service virtualization. But if we kind of build our services correctly, we should be able to work in isolation locally, yeah? But there comes a point where you do want to roll out typically long, bigger term. If you are running everything locally, obviously you're not paying for a remote cluster. That is definitely one advantage of doing that, yeah? I'm running everything in Minikube, I'm paying for my Mac, and I'm paying for the electricity. That's about it. If I start doing remote debugging, I've got to spin up a cluster in GKE or something, and that costs me money, yeah? Oop. However, some systems are simply too large to test locally. And most of the projects I've worked on get to that stage, either through number of services or integration with third parties, all these kind of things. And therefore, I often recommend some kind of like hybrid solution is good. Code as much as you can locally. Use things like separation of concerns, correct abstractions, mock out what you can. But when you do need to kind of spin up something as a in a remote cluster and test against it, there are tools like telepresence where you can literally swap out a deployment running remotely and run it locally. So you can debug using all your local tools as if you were running in the cluster, which I use quite a bit. There's Squash, which is very similar to telepresence, but Squash uses the Envoy proxy. So telepresence swaps out a Kubernetes deployment. Squash basically links into the envoys, the proxies between services. So if you're using a service mesh like Istio, which I'll talk about in a minute, but you can use Squash to do debugging across a whole request. And Squash links in with Delve, it links in with the Java debug protocol. So in theory, you can debug, say you've got like a Go service, a Java service, and a JavaScript service, you can actually use Squash to debug the entire request down through the stack and back up. It's a little, sometimes it doesn't always work as planned, I'll be honest, but it is a complex bit of kit. But I see a lot of promise, a lot of potential with these kind of tools. Just a general comment, something I'm noticing on, so this is a slight tangent, is with these kind of tooling in the cloud space, I'm seeing on one end of the spectrum kind of people bringing the cloud to you. And the other end of the spectrum is putting you in the cloud. And I'm not exactly sure how it's going to go ultimately, and I guess we as customers will decide. But there's a whole bunch of stuff going on about distributed tracing, logging, bringing kind of production metrics to your laptop. Distributed tracing in particular, using things like Zipkin or Lightstep or Jaeger, bringing stuff to you so you can kind of debug and understand what's going on. Distributed tracing are fantastic for complex microservice kind of deployments. There's also things like people are talking about using telepresence and so forth, which is kind of bringing the cloud to me. But on the other end of the spectrum, you can actually now do your complete development lifecycle in the cloud. I know at least 2 companies in London, I can't mention their names, but they have Chromebooks, and their entire IDE and development environment is in the cloud. Developers just use, it's basically fat clients, thin clients, back in the day in Java, and that's kind of fat clients, this is thin clients. We're also seeing like Red Hat put out similar technology. They've got, I can't remember what it's called now, but it's based on eclipsechg, and it's a Kubernetes native IDE, they're branding it as. But it basically means I can have a dumb terminal, a simple terminal, and all my development goes on in the cloud. You can use virtual desktops, obviously, for this kind of stuff as well. I'm not sure which way it's going to go. I find it fascinating. I love my Mac. To be honest, I love coding on the train sometimes. I don't have Wi-Fi. But I do also see the value in this kind of stuff. So just a little slide to get you thinking, as in, there is a choice. And I know big-ish companies in London that are successfully doing both of both ends of the spectrum. So how do you want to verify your system? So again, I mentioned Cindy Sridharan's stuff already. Fantastic. Cindy's really captured the zeitgeist of this kind of stuff. She talks in complex systems, it's really hard, actually impossible, to guarantee correctness unless you use things like formal modeling techniques. Yeah? And the more microservices you've got, the more you're relying on third-party systems, the harder it is to guarantee what you do in development will work. She's not saying there's no value in testing in dev and pre-prod. There's massive value there. But Cindy's also saying, explore these new technologies, because now you're kind of going to have to ship something, and you want a certain amount of guarantee that it's going to work, but you want to be testing in production to really verify it's working. You want good observability, good metrics. You want to be doing things like chaos testing, chaos engineering. Super hot, and if you've got known problems, fix them first. Then chaos engineering is sort of like once you fix all the problems, go into that. But things like canarying and A/B testing, all these kind of things. Now, I'm going to pick on particular, if my clicker works, on canary testing. So I find, like I mentioned earlier on, the whole progressive delivery thing. Canary releasing is very powerful. So where canary releasing is basically where we expose a small fraction of new functionality we expose a small fraction of users to new functionality. Yeah, so we got 1% of traffic will try a new version of our API. These kind of things. Yeah, it is very powerful for you've done all your pre-prod tests, but you're not exactly sure how it's going to function in production, or you're not exactly sure what the users' kind of response to this will be. It's 2 things. You either test kind of for operational metrics, or you can test for business metrics. And we've done a whole bunch of work on this in DataWire, and it's been really, I've learned a bunch. I've made a bunch of mistakes, but we've learned some really good things with customers as well. I think my clicker is on the way out. Sorry. So of course, this is not new. Etsy have been doing this for years. Big push with things like Spinnaker. There was a talk here a couple of years ago, actually, fantastic talk about Spinnaker, which is Netflix and Google's CI/CD tool based on Kubernetes. Excuse me. And they're doing a lot of even automated canarying. So linking up, say, Prometheus with your canary rollouts, and you can automatically roll forward or roll backward, depending on metrics you've specified in Prometheus, which is quite powerful. So I'm a big fan of using Envoy for these kind of things. Yeah, so it is a little bit service mesh all the things. I did a talk here last year actually about service meshes. I'm still doing a whole bunch of work in that space, to be honest. They are not for everyone. Service meshes do add a layer of complexity on top, but they are quite nice for cross-cutting concerns. And things like Envoy has been built from the ground up to handle layer 7 traffic, like HTTP traffic kind of thing. So you can do fine-grained releases based on HTTP headers, based on regex in the path, a whole bunch of cool stuff. Envoy is crazy powerful in terms of how you can split traffic and shadow traffic. Now, it is quite complicated, so there are many control planes, many kind of ways of controlling Envoy popping up. I work on Ambassador, it's the open source API gateway at DataWire. There's Glue from Solo. There's obviously Istio from Google and IBM and so forth. And Console Connect has got Envoy integration now as well. Now, Ambassador and Glue focus on what we call the north-south use cases. So the traffic coming into your cluster. And Istio and Console Connect focus on the east-west traffic, the traffic that's kind of in your cluster, in your data center. And at the moment, the control planes, we think, are kind of different. The control plane for ingress, you probably want SNI, TLS. Ingress, you can't really trust your clients. Whoever's connecting into your cluster could be anyone, yeah? Whereas in your cluster, there is some level of trust. So the difference between north, south, and east, west is there at the moment. But there's plenty of technologies that help you control Envoy to do things like canarying. And now, as an example, when I first started doing canarying in Kubernetes, and I won't spend lots of time on this because I appreciate not everyone's familiar with Kubernetes, but this is a kind of Kubernetes YAML file. We've got a service definition and 2 deployments below it. And for the two, basically one deployment is for the production version of the service or deployment, and one deployment is for a canary sort of version of the service, if you like. And you can kind of fudge canarying by doing 9 replicas of the production and 1 replica of a canary. And therefore, because of the way the services work in Kubernetes, you get roughly 90% of your traffic being served by the top deployment, and 10% of your traffic, the canary, being served by the canary. Now, you obviously need like an ingress on the front of this to expose this service to actual users and so forth. Or you can use something like Ambassador. Glue and others are very similar. But here we define actually 2 services. We have our production service at the top, and we have our canary service just below. And then we can use annotations. And like I say, a bunch of ingress controllers do very similar. Ambassador is fundamentally sort of an ingress controller. But the canarying is so much easier. We can have multiple canaries. We literally just specify weight 1, in this case 1% of traffic will be routed. When I hit the payment prefix, 1% of traffic will be routed to the canary, 99% will hit production. I find it generally easier to manage these things, and Envoy is a bit more sort of fine-grained in the way we control things compared to just using sort of the fundamental units. But you can do canarying with any technology. Fundamentally, yeah. But I would recommend using something like a traffic routing service. If you want to do canarying sort of east-west, I would caution you that get the canarying working at sort of the ingress point. Get canarying working at your API level before trying to do canarying sort of internally. But there's a fantastic operator, another Kubernetes operator, called Flagger, by the Weaveworks team. And basically, it's a CRD, it's a definition where you can define an automatic rollout, and you can define metrics where to roll forward, and metrics of failure where to roll back, and it will automate the handling of Istio for you. So it will gradually roll out traffic in your cluster, and if it goes well, it kind of, you can then swap the canary and production deployments. Another good example of using an operator. Couple of canary gotchas I wanted to highlight. So you do need observability. You do need to understand what's going on in your cluster. You need to understand what's going on in your app. Things like SLIs, kind of core metrics. So I'll focus on some of them in a moment. But you need to then wrap them up into SLOs. Yeah, you need to say a kind of quality of service metric. And you also need some kind of KPIs, key performance indicators. Is my new payment service resulting in higher transactions? Or probably is it not resulting in lower transactions value, things like that. You need to be able to understand, if you're rolling something out, what does it look like when it goes wrong from an operational point of view? And what does it look like when it goes wrong from a business point of view? You definitely need that as a prerequisite. Of course, we're not all Netflix. We're not all Google. We're not all Amazon. To Canary, you need a high amount of traffic. If you're going to rerouting only 1% of your traffic to a Canary, and you've got 10 requests a day, you're going to get like 1 request to your canary. You also need to test representative traffic. I've seen people do load tests with canaries, but they're only testing the happy path. And clients were triggering the not so happy path. And of course, once the canary went through successfully, and then the actual real production traffic kind of hit it over the course of a week, the service fell over because the canary was not representative of what they were actually seeing in production. Do take care with side effects. So a classic, a couple of times, and you might think this would not happen, but it does. In the Java world, like we have tools to basically auto-migrate databases, same with Ruby and Rake and so forth. I've seen some people push canaries that modify the data store, modify the database. And then what happens is they basically break the non-canary services. So they roll out their canary, they're with 1% of traffic, but as they roll out the canary, it triggers a DDL change, updates the database. Only the canary works with the database now, and only 1% of their traffic is going to the canary. I was like, oh my God, yeah. I've seen it happen a couple of times. So be careful with side effects. Think about if you're modifying data stores, you're going to need some kind of abstraction layer to handle the bridge between kind of the non-canary and the canary. So in terms of observability, do focus on the golden signals. So you need to be able to understand latency, traffic, errors, and saturation. There's like the golden signals comes from the Google SRE book. There's also something called use and red, if you want to Google for use and red signals. they're really important to understand top-line operational metrics, yeah? I think when you're first starting with canarying, don't worry about automating everything. It's totally okay to eyeball dashboards to understand if stuff's going bad or good, yeah? In some ways, that's a quicker iteration than trying to automate some of these things. But do create actionable alerts. If a service is completely bombing your entire infrastructure, you need to know about that. In terms of the high volume of diverse traffic, you can load test. I think this is quite a popular one. And you can load test with, say, a flag header. So you load test against production. Be careful with this, obviously, and be careful with your load balancer and so forth. But you can deploy a canary service, load test, but route all of your load test traffic to the canary via a header or some kind of magic. That's quite nice to do. And you are sort of testing your production infrastructure there, which is quite nice too. You can also run synthetic transactions. Yeah, very popular technique. I often recommend running these continually in a production environment. But a synthetic transaction is basically testing a path of how you make money or how you get value. So in the e-commerce world, a synthetic transaction we often run is, can I browse for products? Can I add a product to the basket? And can I check out? And we have like fake products and fake users, and we continually automate the running of these things. And if at any one moment, if I push a release and suddenly my fake user can't search for a product, or my fake user can't put something in the basket, big alarms go off, and we fix that. But you can, and we often use things like BDD-style frameworks. So Serenity I use in the Java world quite a lot, but there's many BDD behavior-driven design frameworks. Cucumber, you can specify Cucumber definitions, that kind of thing. But these are great ways to test in canarying. You've covered all of your use cases. Yeah, really important. I mentioned that take care of side effects. So I've often used so be careful with DDL. And if you are calling out to third-party services and you don't want to trigger side effects, things like service virtualization, hoverfly, and a bunch of things are good to go. I've only got 7 minutes now, so I think I'm not taking too bad time. I would mention, in terms of observability UX, yeah, a lot of engineers want to create a dashboard that looks a little bit like this, myself included sometimes. Actually, you want to create this and make it super simple. This is where UX matters, yeah? I've gone in some organizations with like amazing walls of dashboards, and I'm like, tell me what it means. And no one can tell me what it means. Yeah, looks pretty, but that doesn't do anything. Yeah. So moving on to the next question. Do you want to implement guardrails for your dev teams? So larger teams do want to provide a lot more control on how people work with the system. Startups and SMEs, probably not. Yeah, probably want to sort of allow team independence. And like I mentioned with the Netflix thing, there's this whole notion of hybrid, where you can kind of offer this PaaS, but then also allow an escape hatch where people can do their own thing. Yeah. And on this note, as in, a fantastic talk by Melanie Sebula at KubeCon London recently. She talked about how the Airbnb team have created a whole bunch of tools on top of Kubernetes to orchestrate, they provide utilities, but also some guide rails. It basically wraps kubectl so you can't do silly things. Yeah? And we've actually created similar tools in DataWire now. Sort of certain utilities we wanted to add on top of kubectl. So we use kubeapply, kind of like our tool, which is going to wraps kubectl to provide a few guardrails. At the start, we didn't do that. We were just all kubectling, it's fine. But when you're in production and so forth, you probably want a bit more care as to what you can do. And putting a wrapper around some of these things is a good way of doing it. Of course, you can kind of buy these things, and OpenShift in particular has some fantastic enterprise-friendly tooling that wraps on top of Kubernetes. Yeah. Obviously, it's a trade-off because you're buying into OpenShift's abstractions, which are on top of Kubernetes, but it's a choice. So just final thing, security guardrails. A couple of great operators I want to mention. If you're using RBAC a lot, there's a fantastic operator called the RBAC operator, which basically changes the role-based access control into more of a declarative model. We use Cert Manager, a whole bunch for automating TLS certificates in Ambassador. It's an open source framework using like Let's Encrypt and so forth, and you can automate renewal of your TLS certificates so they never expire. Or they do expire, but they get renewed. And finally, there's Kritis, which is a newish product, but it's a way to create kind of policy on what you can and cannot deploy into production. Yeah? Google have really only got the best implementation of this on GKE now, but you can define policies to whitelist, say, CVEs. We know this container has got a CVE, but we're cool with it because we've kind of battle tested it and it's good. And you can also say that only things can get deployed into production if they've got a cryptographically signed QA stamp. So your QA team tests your container, signs it kind of thing, and then you can only allow deployment based on that signature. So there's a bunch of cool stuff. Kritis and Graphius are tools to check out as well. These are more examples of how to sort of extend Kubernetes. Right, final focus. Where to get started, yeah? I mentioned this kind of thing earlier on with different teams, different stages of products, kind of, you're using the central platform, where to get started. Now, if you're mainly a newish company, you've got product market fit, but you're kind of ramping up and you're doing lots of prototyping, this is my advice. Dev and test, I think local as long as you can, then go hybrid with something like telepresence. Releasing, I think, pushing canaries is really quite good. Maybe if you haven't got enough traffic, doing load testing with synthetic data is good. Guide rails, YOLO, yeah, you only live once. Push it, push it, push it. It's all good. You haven't got very many customers at this point, it's fine. Where to focus? In a dev loop. Get rid of the waste when you're trying to go really fast, yeah? And CI and CD, haven't covered them lots in this talk, but continuous delivery and pipelines, basically automating your pipelines, super important. If you're more in the kind of later phases, production phases, the hybrid thing works quite well, sort of testing some stuff in production, but being very careful about routing traffic. Probably be using stage environments or namespaces in Kubernetes to kind of provide isolation. Sometimes you use separate Kubernetes clusters, to be fair. That's really good isolation. You're doing some canarying, probably, but you're also doing a bit more pre-production testing now. Guide rails, this is where we started developing a whole bunch of wrapper scripts and sort of a few things that there were some obvious gotchas when we were deploying, what we wanted to stop doing. Yeah, so we were putting kind of scripts on. We were also automating some of our observability at this point. We put Prometheus in. We had a good understanding of how operationally what the cluster looked like when it was running well. We had an understanding of what to look out for when the cluster was going bad. And we were codifying the best practices we were learning in sort of our, we had like automatic service generation templates. So if we wanted a new microservice, we'd go into Jenkins, type in the name of the service, press the Jenkins button, crank the handle, and out pops a new, say, Java service that was already linked up to our monitoring. Had all the libraries built into it, like using Maven artifacts, that kind of stuff. Had all the hooks into the BDD testing and a bunch of stuff. So stuff that we had identified internally as best practice, we were codifying in our scripts, codifying in our archetypes for Java and for Ruby. Observability is super important. If you're kind of at the mission critical stage, you're probably doing a bit more local testing with a kind of hybrid staged environment. So you don't want to be messing around on live too much. Messing around in production is what I'm saying. You're doing probably a whole bunch more pre-production testing. Definitely still canarying, but probably you want to make sure what you're pushing is super good before you start canarying. Guide rails tend to be a bit stronger there. Things like observability, debugging get more important, and in particular, being able to recreate data or recreate environments. That when you're in this stage, when stuff goes wrong, it's really bad. So you need to be able to understand what went wrong and recreate it. So good metrics, good observability, the ability to sort of clone databases, clone environments, I found is really beneficial at this point. So hopefully, pretty much good time there. Wrapping up, this has been a bit of a whistle-stop tour, as many of my talks are, and I can talk a bit fast sometimes, I apologize. You can watch the video on YouTube back at half speed, that's what I like to say, yeah. But what I'm trying to say to you is a couple of things, really, is developer experience is really important. It's about minimizing the friction between an idea to value. Yeah, and I think we as engineers sometimes forget some of this stuff. It's actually really good to focus on. How you construct your platform massively impacts the experience. Most people, like myself included, get a bit excited about Docker, about Kubernetes, but without realizing often that when stuff is new, it's not fully formed, and you have to create lots of extra stuff around the edges to get it working. And we spend so much time things like local development, continuous delivery, release control, but we often spend the least amount of engineering effort there. We make our systems really good, kind of thing, we get our Jenkins up and running, but we don't really curate the experience, yeah? And my argument really today is, think about these things. As engineers, you're going to be using these build tools, these release tools a heck of a lot, therefore, invest appropriate time in them. And at that point, I should say, thank you very much for your time.
So, thank you, Daniel. Are there any questions? We have time for 2 questions, I think. Yes.
You didn't mention versioning, But when you had this slide about the YAML file and the Canary releases, I was thinking about our approach of versioning. So when we started with working with Kubernetes, I had the feeling that we had to tag stuff, and then we found out that when we tag stuff, it's already old because we're pushing things quite quickly. So we ended up with just having now the normal commit versions.
Like chars, git chars.
Yeah, the chars.
Yeah.
So what's your approach? Do you still have tags, or is it?
Yes, it's a great question, and probably one that I've covered in other talks actually. But if you look, like what we were doing, like say with our deployments here, we did have the app payment version 132 and version 124. So we often versioned our container artifacts, but we just use labels for kind of production deployments. Makes sense. And what you're doing to us, git char, I agree with you. Particularly if you're operating at a certain scale, versions, much as I love semver, like semantic versioning, almost becomes meaningless because you're pushing so much. Semver your APIs, because customers are consuming them, you want to tell them when there's a breaking change coming. But internally, I'm using git chars a heck of a lot, yeah. And I must be honest, so I work as a consultant and I work with DataWire, and nearly every company I bump into does something different. Yeah, definitely versioning is really important, but like a lot of things in that space, the context is key. So perhaps you and I can have a chat afterwards. It's really you've got to know kind of how the environment's set up and how the pipeline's set up, those kind of things. But good call, versioning is really important as an overall concept.
Is there another question?
I think one behind you.
Awesome.
Great talk, and we are actually establishing a developer experience unit as we're speaking.
Interesting.
With exactly all that, what you're mentioning there. Main challenge is getting money for that.
Yeah.
And convincing management that this is really worth the effort. So, I mean, I fully agree with you. Building up developers mastery is our term for all this local development stuff you mentioned. But the main challenge is, how do you get money? Do you have a business case? Can you put it into euros, why it pays to have a central team developing Kubernetes and not 5 or 20 teams developing Kubernetes for themselves and so on.
Yeah.
So if you have anything that helps in this area, I would be very thankful.
Yes, I mean, definitely have a chat afterwards, perhaps in more detail. But what I get this question a lot, to be honest. I was in Portugal not long ago and I had exactly the same question. And the two books I use for this is the Accelerate book. I don't know if you saw, put up earlier on by Nicole Forsgren, and the DevOps Handbook. And they too talk about ways of creating business cases. And what you can do, I always recommend experiments are really valuable. So, and another thing that can often trigger, say, experiments to hypothesize, hey, if we create a central team, it will be more cost effective, is you can often use a good crisis, as they say, yeah? If something's gone wrong, you've deployed something super quick and it's broken the whole system. Well, that can often be then leveraged into, look, hey, trying to root cause. Here's the root causes of what went wrong, or the steps. There often is no root cause, but the steps that led to these things going wrong. And if you can identify some of those things you could perhaps have fixed with automation or code reviews or these things, that can often be a way of getting into management saying, look, give me 10,000 euros and I'll run an experiment for a month. And if we can show some metrics in improving lead time, or show some metrics in improving a failure rate or deploy failures, then that can be a way to get a catalyst going. It's not an easy, I'll be honest, I can see you skeptical. It's not an easy thing to do in general, but.
Talking about how to get 20 million.
You and I can chat afterwards, yeah? Yeah, I hear you. Those, for bigger, more enterprise things, again, I still recommend doing pilots. The pilots are often an effective way, but let's have a chat afterwards and perhaps I can pick your brains and learn some stuff and share some ideas that I've done in the past. Time?
So.
Just that possible answer. I mean, you are an engineer. Sorry. Yeah, you are an engineer. You can vote with your feet instead of trying to convince your management, which takes a lot of time, a lot of resource, a lot of the energy for so little value. Just vote with your feet and go find a company that already has that baked in. And
He's the manager.
That works well, except for those who go to a company to change it. Sorry.
yeah, it's another view of things. Huh?
On that controversial note, but good call. I often know that thing is if you can't change the situation, change the situation. Yeah.
So, then thank you very much, Daniel, for your insights. And I think you will be around at the conference.
Yeah.
And so if you have any questions, don't hesitate. Ask Daniel, he's really nice. And
Thank you.
enjoy the discussions and further talks. Thank you very much.
Thanks. Thank you.